Well, welcome everyone. Thank you so much for taking the time out of your day to join our webinar, Preventing Cloud Cost Overruns in Your Cloud Native Environments. I do have a couple of housekeeping items for today. This webinar is being recorded and will be shared after the webinar on demand to watch at your leisure. And then we are also going to save Q&A for the end of the webinar. So feel free to put your questions in the Q&A chat and or raise your hand and we will get to you then. And we would love to hear from you and make this as engaging as possible. So we would love for you to have questions and interact with our speakers today. That being said, I would like to go ahead and get the webinar kicked off by introducing our speakers. We have Boris, who is our Principal Solutions Architect at Nirmata. We have Chip, who is our Product Manager at Kubecost. And then we also have Sai, who is our Principal Solutions Architect at AWS. That being said, I'm going to go ahead and give it off to Sai to get us started.
Awesome. Thanks for that intro, Randy. Hey, folks, Kyverno here. I'm a solutions architect at AWS, and you may know me from a show that I run on YouTube called Containers from the Couch. We've really got the dream team here today with Nirmata. We got Kubecost and AWS, of course. But when we're talking about FinOps, I really do feel like the solutions that we're going to be talking about today, and the key word here is proactive, but helping you proactively control your costs and not freaking out after the fact, ideally. So with any kind of FinOps cycle, really here at AWS, or I imagine with any cloud provider, we're going to see kind of three phases to this cycle that customers generally go through. Now, this first phase is interesting, but it's something that it's really just observability at the end of the day, knowing the data that's out there, how much something costs, being able to see it. That's a property of the system that's being made visible, essentially the fundamentals of observability. But the key word with FinOps is really that operations aspect. What are you doing with that data itself? And that's when we come to things like the optimize and operate phases of this life cycle. And really where the solutions that Chip and Boris are going to talk about today with Kubecost and Kyverno come in, is how do we take that data and then create meaningful impact changes with it. I think one of the stats that I saw recently really kind of blew my mind here. But most companies, most organizations, you can imagine that they probably spend a lot of their money in response to customer demand and load of compute going up and down, totally unpredictable costs. Yes, this is true. But the stat that I saw from CloudVisor was about 30 to 40% of an enterprise's cloud bill is usually wasted due to over provisioning or lack of cost management. Now, that's significant. Even if your customer base spikes 40% in a day, that wouldn't account for the amount that enterprises are just wasting on over-provisioned resources. And I think the first step of that is, of course, getting insights into what that is. Next slide, please. Now, one of the things that we talk about today is solutions that work natively and integrate really well with Kubernetes. And the thing is, FinOps is not a new thing. Even from the early days of EC2, customers wanted to know how much things cost. But with just EC2, it's a lot more straightforward. I think the most complicated thing you could consider are things like, spot instances or savings plans or reserved instances. But still, for the most part, auto scaling to the level that Kubernetes does it. Yes, auto scale, auto heal, auto magic, everything is awesome, but comes with a disadvantage that you don't really have a linear or static, cost that you can follow. It really does depend on a lot of different factors. In addition, Kubernetes makes this harder because these pods are running on nodes that are automatically scaled up and down. The pods themselves are automatically scaling up and down. There's other resources outside of Kubernetes that your services need, things like databases and that kind of thing. And you put all of this together and you realize that accurately predicting costs on Kubernetes is actually pretty hard. And what we're seeing is that only 22% of organizations that we surveyed, that the FinOps Foundation surveyed, are able to predict their costs with 5% accuracy or better. So clearly a problem at hand here. That's all I really wanted to talk about today, to at least introduce the topic from a perspective of AWS. Chip, let me hand it to you to talk a little bit about what solutions are in place to help customers manage these challenges.
Thanks, I. Yeah, my name is Chip Zoller. I'm a product manager here at Kubecost, and that's a good segue into what Kubecost is, why it's useful, and then we'll get a little bit later in how you can actually use this combination with AWS Kubecost and Kyverno/Nirmata to be able to not only see these things better, but really ultimately stop them before they occur. So just as an overview, Kubecost, so we provide software that gives you real-time cost visibility and insights into your Kubernetes clusters, so in a very granular manner, as well as providing your cloud costs all in one central place. This is software that runs on truly any Kubernetes environment. Obviously, we're with our good friends and partners, AWS, and so we integrate very tightly with AWS and all of the other clouds to not only just show you what the rates are supposed to be, but what you're actually spending in your bill by pulling that detail in. We've got something like $3+ billion across all of the customer and user base who use Kubecost. So it's a tremendous amount of spend that's being monitored, and that number only goes up. We've got customers around the world that use Kubecost. It's sort of kind of become the de facto standard almost in getting granular Kubernetes costs. And you can see there on the right, we've got a bunch of leading companies that use it. To give you an idea of what some of the features that Kubecost offers, this provides accurate and detailed, and that's the key, detailed numbers for your Kubernetes spend. A lot of costing tools, and maybe some of you are using things like spreadsheets or something else, in the past have kind of just given you one lump sum, like this is what your cluster costs, or maybe it goes down to namespace. But with Kubecost, it'll go down to the individual container level and show you exactly what you're using and exactly what that's costing. This integrates with all the major cloud providers, so you can do some very interesting things like billing reconciliation. This will give you the percent accuracy once the cloud provider makes the bill available. So not just here is what the general public would pay, but taking consideration your reserved instances, your discounts, all of those things, it will actually reconcile what it thought you spent with what you actually spent. And super valuable being able to pull in cloud costs. So you've got your Kubernetes spend that are your pods and containers, but you also have resources outside of that. So if you're running one of these cloud clusters, there's a cost associated with using the service. There's a cost associated with running the virtual machines that power the service, so on and so forth. So it'll pull in those extra cloud costs and show them to you in one place. That one place is not just on a singular cluster basis, but federated across your entire estate. So gone are the days where people are typically running one cluster, one mega cluster, because Kubernetes in the earlier days, when there weren't these turnkey services, was really difficult to stand up. And so organizations tended to have one large cluster. There tended to be more waste. So you typically have a bunch of clusters in your estate, and Kubecost can federate all of those together and show you what all of those cost in a single place, rolling costs up together, allowing you to slice and dice them, all sorts of good stuff there. It'll provide you efficiency numbers, carbon costs, anomalies. All of these things are based on cost allocation, so what you're using compared to what you're spending for that. It is able to give you savings opportunities, so not only providing you some insights on where and how you can save money, but even comes with automation to take that into consideration and to realize those savings for you without you having to do really anything else. It's got reports and alerts. No monitoring and visibility tool would be complete without those, so you can get reports on what you're spending and where, send alerts whenever things get too high. We've got budgets, which we'll showcase here as part of the demo coming up a little bit later. But with a budget, you can set a maximum spend on any given collection that you'd like and have alerts tied to that, and many, many more features. Don't have time to go into all of those, but this is sort of a general overview of Kubecost. And Sai laid out pretty well like what the problem domain is and why there's value in solving for it. So Kubecost can be a tool that you can layer in your environment to leverage to get visibility. And as we'll show coming up here, how you can use the power of Kubecost with something like Kyverno to really take that a step further and prevent those cost overruns before they occur. So with that, I'm going to hand it over to my friend Boris from Nirmata.
Yeah, good. Well, I guess at this point, afternoon if you're on the East Coast, everybody. My name is Boris. My last name is very complicated in Eastern European. We're going to skip that. I am a principal solutions architect here at Nirmata. And before we dove into Kyverno, as I'm sure some people are already familiar with it, I wanted to just kind of walk through who Nirmata is first and why we are here with Sai and Chip. Kyverno was created by Nirmata. It was kind of a project that our founding team created, and by looking at where is the operation of Kubernetes falling short. Kind of Sai hinted at this at the start, but Kubernetes is great. Kubernetes solves a lot of problems. It's the Swiss Army knife, but where kind of the thinking behind people who operate Kubernetes falls short sometimes is great, we got past day 0, day 1, but like what happens on day 2 when I have to actually operate this at scale and run this at scale and govern this at scale outside of the actual, how do I do upgrades or kind of the more technical bits? How do I make sure that there are guardrails and that this doesn't turn into the wild, wild west? We donated the project to the CNCF, and hopefully if you're attending KubeCon NA this year in about 2 months, 3 months time, the project will be actually properly graduated, which becomes a pretty big deal, obviously, because it does establish the ideas behind what governance should be and what policy should be within the scope of Kubernetes is an actual solvable problem and important problem to tackle. Next. All right. But ultimately, what we think of the world is, or kind of the world is shifting to, is obviously, I think everybody's LinkedIn feeds has been bombarded with platform this, platform that. Gartner did indeed go out there and do a little bit of research on the matter, and in very short order, almost everybody is going to have some form of a platform team established within their organization. This is great. However, what it does mean is that now you are having to figure out, how do I do day 2 operations for different pieces that you're putting together and connecting into, a coherent end user experience. So where we're kind of finding the most problematic areas of this new paradigm is misconfigurations, costing, kind of those types of problems needing to be solved, and needing to be solved with a simple to understand engine that allows you to scale the simplicity of what Kyverno brings to the Kubernetes world across multiple tools. Obviously, today we're kind of focusing on how this problem is being solved when it comes to specifically costing, but you are able to scale this past just the operation of a cluster.
Next. So Boris, I just had a question on that last slide, and it's I think clear to me, but maybe for some of the folks watching, can you talk a little bit about so Kyverno is a policy management enforcement engine. It runs in Kubernetes. It lets you create policies for really almost anything. And in the demo that we're going to see shortly, we're going to see how we can make policies based on the costing data of how much something costs. How does Kyverno help with platform management? Like if you mentioned platform teams, creating things like internal developer portals, which is the more cool thing nowadays. But before it was just establishing pipelines. There was GitOps. Before that, it was DevOps and all of that fun stuff. Where does Kyverno fit into that?
Yeah, that's a great question. I think this is a conversation that I have all the time. To me, platform is just kind of the repackaging of all of those ideas that you just mentioned into a new kind of umbrella. But ultimately, where Kyverno fits is in every one of those steps. And why is this important? Is because you are now able to integrate with all of the tooling of a platform and allow you to what we at Nirmata kind of refer to as shift down. Thus, when what that means is that you can run Kyverno in your pipeline. So before your code ever gets to your Kubernetes cluster, you can have an understanding of the state of the world and where there might be pitfalls. You can run it in your Git repository. So as soon as you commit code, you can now get an actual detailed report from Kyverno with the exact same policies that you're using on your running infrastructure to tell you and give you information and insight on, hey, these pieces of code will introduce problems, will introduce issues down the line. So the idea is that although Kyverno was born as a Kubernetes guardrails tool, that you can now expand it and utilize it to govern the entire platform and how those pieces produce kind of valuable information can change with the context that they're executed in, rather than you have a problem, right? We've all stared at a kind of blank page and trying to solve a problem with, I have no information, I have no idea, this is giving me some generic issue, how do I move on from here?
Makes sense. By the way, I love the shift down thing you mentioned. It's, shifting left is great. It's essentially the idea stemmed from, do testing earlier in your development life cycle. But at some point, you have to stop shifting left all of your responsibilities onto the dev and shift down. Kind of what you're referring to here. Still relatively new concept to me, the term, not the concept itself. But essentially to push those responsibilities onto the platform. So that's what the shift down is referring to. Don't make your devs deal with it. Leverage the platform tooling to make your life easier. I really like that.
Yeah, no, for sure. And I think the unifying idea behind, kind of what you said is that shifting left offloads to one team, shifting right offloads to another team. And obviously, like many things in life, the truth is somewhere in the middle, and enabling and giving context to the middle enables the teams to actually coherently work together, rather than kind of throwing grenades over the fence and hoping that somebody else will solve the problem for you. So yeah, I totally agree. That's kind of why we're trying to shift the mindset around the whole shift star working relationship. But in relation to costs, as I was mentioning earlier, what the CNCF actually found a couple of years ago is that misconfigurations of both your infrastructure, your actual code of your platform have a true, real world cost. What you're seeing here is a per cost basis. Now, I believe nobody runs a single cluster. Otherwise, Sai and AWS will probably be out of a job, right? Scale that to an actual account and an actual production system, and you can see that there is a very, very real, hey, I'm going to pay for this. How do I tame the beast before this affects me? Like everything, obviously, you're never going to reduce this to zero. However, if you're enabled to solve these problems at scale with speed, you can reduce that quite significantly. Hit next. All right. So why policies, right? Why are we talking about Kyverno? Why are we talking about, what we're talking about here is obviously today we're focusing on Kubernetes, but you know, as I mentioned at the top, and as Sai mentioned as well, Cube does a lot of things and lets you decide what that means for your organization. So by default, Kubernetes can be considered insecure. Right, that's why there's a ton of NIST standards that people apply. That's why there's things like PCI that apply to Kubernetes. You need a way to kind of bundle all those up and create them in a generic manner. Because what Sai already mentioned with the kind of shift star paradigm, you need a unifying, let's call it, language in order to share the responsibility of solving problems within your platform, within Kubernetes, between your developers, between your operations, between your security teams, and even business logic, right? You need a way to express that, and you need to be able to apply it, and you need to be able to utilize it in Kubernetes and outside of Kubernetes. With policies, again, you can drop something, a bundle of policies and immediately enforce NIST 853, or if you're into the zero trust world and service mesh, maybe the NIST 800, 207, 207 series, which deals with kind of zero trust. You're able to do this and pretty easily and quickly drop it in and scale it with the help of kind of Nirmata, scale it across infrastructure and across everything that you do.
And Boris, if there's one thing I can just butt in here. I feel like I've been butting in a lot. Sorry. If there's one thing that I've recognized from customers here, it's that the reason why Kyverno is so great for writing and implementing policies. It's Kubernetes native by design. You don't have to learn like a new language for policy writing like Rego or anything like that. It's YAML based. It just works. And you mentioned part of the CNCF. Kubecost as well, underlying, I think the open cost is also part of the CNCF. But I think that's important for customers. If customers are choosing Kubernetes, then they're buying into the open source landscape, and they want to know that the platform and solutions they're using are also bought into that landscape.
Oh yeah, for sure. I mean, I can definitely tell you that a lot of the folks that I interface with on daily basis are specifically choosing Kyverno as their engine for the sole reason that, as I mentioned, it is YAML based. Does not require another language, and it allows people that are innately familiar with Kubernetes concepts and people that can view text and read text like human readable text and understand what is going on. Even today, with what Chip is sharing, going to demo in a second, you can actually follow kind of the logic and follow what's happening without ever seeing a Kyverno policy, because it is meant to be human readable at the end of the day. So yeah, that is very much a nail on the head for sure. It is a big win for all kind of parties involved when it comes to policy and when it comes to governance and when it comes to kind of creating the walled off garden that makes sense for your organization. All right, hit next. All right. So ultimately, what are we trying to do? We want to give you a way to kind of what Sai and I have been discussing a little bit out of band, is give you a governance platform that you can use in your infrastructure, you can use in your pipelines, you can use in your clusters, you can use it in your repositories, and have kind of that single pane of glass of understanding, hey, 100% of my systems are compliant with whatever our internal best practices are. I will use AWS, EKS publishes EKS best practices. Those are currently on the Kyverno website as a bundle that you can drop in on any cluster, and you immediately know that you are kind of compliant with what AWS says the best practices for those systems are. But being able to kind of see that and expand that beyond just Kubernetes is ultimately what we're trying to accomplish here at Nirmata by integrating ourselves, with tools like Kubecost, with Argo, with AWS and other hyperscalers. Utilizing that simple to read YAML in multiple places is extremely, extremely powerful. And I believe at this point, we got one more. And yeah, let's introduce, I'm going to throw it back to Chip to introduce the actual demo of kind of how we tie all of this together into a coherent solution.
Thanks, Boris. Yeah, so we've talked a lot about what the sort of cost base is, what some of the tools that are out there have introduced, Kyverno and Kubecost. Now, like to kind of flip over and show and talk about first, but then show, all right, let's look at the details here. Let's see what this looks like combining the two. So whenever you have a costing tool like Kubecost, one of the inevitably popular ways that people need to be able to visualize costs is in different ways. We call this aggregation. So one of the ways to do that when you're talking about shared clusters, which today most clusters are shared in some fashion, are by things like metadata, chiefly labels. So when it comes to a policy engine like Kyverno, you can do things like enforcing that all of the workloads that land on that cluster have those labels that you use to gain that visibility. And with Kyverno, you can even go a step further by writing those labels. You can even do it for existing resources, which is not something that other policy engines can really do. And so in that regard, using this combination allows you to maintain visibility so that you don't have costs that are unaccounted for. Because if the workload's landing on your cluster, it's not that you're not paying for it, you are paying for it, but it's not being attributed to the right cost center or showing up on the report that you expect or the dashboard or whatever the case is. So being able to use these tools together can ensure that you have the first step, which is just getting visibility in an accurate and consistent manner. One of the things that we've talked about as an aspect of costing is external resources, so cloud resources. If you're running Kubernetes in EKS, for example, you create something like a persistent volume that's an EBS type or a service of type load balancer or an ingress. These things result in cloud resources being spun up. And those resources can be attributed back to the Kubernetes clusters, but you may want to be able to, in addition to getting visibility, which you can do with Kubecost and seeing what those cloud resources are and how they're related back to my cluster, you maybe want to put some governance around that and saying, you know what, I'm not going to allow 500 ELDs to be spun up in this cluster, or I'm not going to permit services of type node port. For whatever the case is, you can use this combination with Kubecost and Kyverno, and really just Kyverno at this point in time, to make sure that those things are prevented, so that rather than you seeing that in your report and realize, oh man, somebody accidentally messed something up and we were supposed to get one ingress controller, but we got 100 or whatever the case might be. You've already spent the money. The money's gone. So you want to be able to prevent those things before they happen. And that leads into the third bullet here, which is what I'm really going to dig into, which is preventing spend proactively from the Kubernetes angle. So again, visibility tools are great. They show you what you're spending. Kubecost shows you that in a very, very granular and accurate fashion. But observability tools are just that. They allow you to observe. And when you're talking about observing costs, you are talking about visualizing costs that you've already incurred. The money's already been spent. Somebody messed up, or maybe it's just, you had an extra bursty month and you spent an extra 10 grand, whatever the case is on a namespace or on a cluster. Or in some cases, and we've had customers actually do this, unbeknownst to them, spend an additional like 50 grand because of a misconfiguration or whatever the case might be. So you want to be able to get an understanding of where those costs are going. That's the first step. But the second step is, once you understand that, being able to put some guardrails around preventing that spend from leaving. Because I think we can all agree, if you cannot spend the $20,000 that you didn't expect to spend, you'd rather do that than going to a tool and saying, oh yeah, well, we owe so-and-so cloud provider an additional 20 grand. That's going to put us in a hard position. So what we ultimately want to be able to do is say, tool, in this case, Kyverno, you're already installed on my cluster. I've got Kubecost that's out there that understands deeply what's going on. Kyverno is an admission controller. Let's combine an admission controller that understands what's coming in and out of the cluster with our cost monitoring and visibility tool to be able to say, you know what, rather than just letting things through and reporting on it later, let's get some sense up front of what that's going to cost and how or if we should allow that or not. So as you can see in the little diagram here, and this is where I'm going to flip over and actually show you the good stuff that you probably came for. As a user, I'm going to send a resource to the Kubernetes API server. And because we have Kyverno installed in our EKS cluster here, Kyverno is going to be able to call out to Kubecost, which is also installed in the cluster. And Kubecost is going to provide information back to Kyverno, which it will then use to decide whether it should be allowed or not. And if it's allowed, it'll get persisted to etcd and it'll run. And if it's not allowed, it will get denied. So I'm just going to quickly flip over and show the first demo here and make sure that I've got my port forward that's still going. So, you know, one of the things that you can do here, and I'm showing a Kyverno policy, is what we want to do is check the cost of a deployment that's going to get created in the cluster and get some sort of feedback from Kubecost to understand what this thing is going to cost and then make a decision. So the idea in this is maybe you want to put guardrails around how much any individual deployment should cost and then use that as a factor as to whether you should allow it or not. And one question you might be asking is, all right, cool, that sounds good, but how does it really know and how accurate is it? Kubecost has an ability called a cost predictions API. And the cost predictions are going to be based on your cluster and where the workload is being proposed to run, but it's going to return a prediction based on what you're actually spending. So if you have reserved instances and discounts and savings plans, in the case of AWS, once you connect Kubecost to your AWS account, the predictions are going to be based on that. So it's not going to be just based on the public rates, but it's going to be based on the predictions, that is, we're going to be based on what you are expected to spend in that cluster. So as Boris mentioned, and this is an example of a Kyverno policy, as you can see, there's no programming language to be found here. This is all YAML based. And even for those of you who have not seen a Kyverno policy before, although this one's a little bit more complicated than most, you can probably figure out what we're doing. So I'm not going to boil the whole policy down, but just want to call out some chunks. First of all, we're going to watch for the creation of deployments. And whenever we see a creation of a deployment, we're going to snap into action. We are going to call out to Kubecost and we are going to ask it, hey, give me a prediction of what this deployment that you're actually seeing someone's trying to create. Take a look at that, determine where that's going to land, and tell me how much that's going to cost a month. And we're going to take that as the predicted cost. And in this case, we're just defining a maximum cost that's in the policy itself. And we're going to up-level this in just a minute by enhancing it with another Kubecost feature called budgets. But maybe you want to define what an individual maximum cost should be. So in this case, I'm just saying $10. And you can imagine that this could be any number that you want. This number could be stored in a config map, even the label of a namespace, whatever the case might be. But just as an introductory demo, that's what we're going to set the max cost as. And then we're going to do a simple deny. So we're going to compare what Kubecost says is the predicted monthly cost. If that's greater than the maximum cost that we've determined, then we're going to deny it. And we're going to show you what Kubecost is saying that it costs. So before getting into that, though, and Sai mentioned this in one of his slides, the first step is getting visibility to understand whether you should or should not do something. So one of the things that Kyverno has the capability of doing, and I'll just go back up here and show a mode of audit. So validation failure action in audit means that in this case, we're not going to stop anything from being created, but we are going to tell you about it. And the way that Kyverno does this is with a really neat capability called policy reports. And policy reports are just another Kubernetes resource. It's a custom resource that is a policy working group resource, so it's not Kyverno proprietary. And in those reports, which occur in your cluster and can later be viewed and scraped by Nirmata tools like Policy Manager, you can get a log effectively of what's happened, and in this case, what it's cost. So I've already created a resource in a namespace that should have such a policy report, and I'm going to get those policy reports back here. So I created this deployment earlier, and this is with the policy that I just showed a second ago, this max cost where the cost is built in. And this was in audit mode. And this had the effect of creating a policy report. Now you can see I have two deployments in this namespace. One is called BusyBox, one is called not Nginx. And so let's just take a look at this policy report to show you what you might expect to see as the first stepping stone in order to getting proactive cost controls. So as you can see here, I'm looking at the policy report, which Kyverno generated after observing a new deployment and after checking with Kubecost to get the predictions. Now, in this case, because the policy was set to audit mode, the resource was allowed, but it actually failed as the result indicated here. So it showed that it failed. And it shows you in a message here that at the time this was created, this cost $34.03 for a month. And when it was greater than the maximum allowable amount, which, as you saw from the policy, was $10. So technically, this would have failed if the policy were in enforce mode. So policy reports are a great way with Kyverno for you to be able to see the would-be effects of something without having to take disruptive action. Now, ultimately, in order to get
Chip,
the proactive cost control.
Sorry, I just want to understand one thing. So that number, that $34, it's actually predicting for that deployment running on that node based on the previous expenditure of a similar type of workload on a similar node. That's how much it would cost. So that's why it does in fact take into account things like reserve instances and savings plans and spot instances and all of the other goodness that customers can do to save money.
Yep. It will actually look at everything that's configured in the deployment. And this is an example of that deployment. It's taking a look at the replicas and the resource requests, which function as reservations basically in Kubernetes. And it's going and saying, all right, I know where this could land. I know how many replicas it is. I know what CPU and memory costs on those node types. Again, not just from the public rate cards, but from your account, your past billing statement. I'm pretty confident that to run this for a month is going to cost this number, which is a summation of all of the replicas and all of the resources that that's going to consume.
Got it. And because everything in Kubernetes runs in the controller mechanism, controller loop, is Kubernetes going to keep trying to make that deployment until someone comes in and says, "Hey, you're not actually supposed to be here," and deletes it?
No, in this case, because it's in audit mode, it's just going to stick around. Now, Kyverno is going to periodically just check again and see if that's going to be allowed. But because this policy is still in audit mode in the cluster right now, and you can see that, which will flip, well, actually replace this with another one, it's not going to take any action. So you can introduce a policy like this after you already have workloads that are in there, and it can give you information in the form of a policy report. So it's not going to disrupt anything. Only if you flip a policy, or we're going to actually just create another one in enforce mode, things after that point in time, it will take action on, but not existing things before that time.
Got it.
Yeah.
That makes sense. And that Kubecost instance, is that running in the cluster or outside? And
That's running
like,
in the cluster.
it is running in the cluster.
Yeah.
Okay, excellent.
So we're in an
Uh,
EKS cluster right now, and we have Kubecost installed on this cluster. And this cluster has been, this cluster is connected to our AWS billing account. And so Kyverno is installed on the same cluster, and Kyverno is talking to Kubecost locally.
Okay, gotcha. I saw the HTTP colon and I was like, oh well, maybe it's taking an external URL. We could probably simplify that down, huh? By just making it the service name instead of the fully qualified name. Anyway, that's neither here nor there. But okay, that's interesting.
Yep. So that's what a policy report looks like in this case. And again, this is with the maximum cost that's statically defined. So this can be super useful to you if you want to define these things in a centralized location that's part of your Kubernetes environment. But what we actually want to do is leverage another capability of Kubecost called budgets. And I'm going to flip over and show budgets here. So this is my Kubecost portal that I've got running in this cluster, and I'm not going to go through everything. We just simply don't have time. And also this is really about proactive cost controls. But one of the cool capabilities in addition to predictions that Kubecost is able to do is define a budget. And a budget is what it sounds like. It's a maximum amount of spend that can be associated with any type of resource. So let me just go through and show you what types of things are available. So you want to have a budget cap. That is the maximum amount that you can spend. Budgets have to reset. You can configure this reset for a weekly reset or a monthly reset. And then the workloads that you want to group and be applicable to a budget. So as you can see here, a namespace or a cluster or even a label. If you wanted to be able to say, I want a label-based budget. So anything that comes into this cluster that has foo equals bar is subject to this budget. We can then use Kyverno to go and ask Kubecost about this. And so that's exactly what I'm going to do here. I've created this budget called CZ demo. If you look at the details, this is just based on the default namespace. But what this budget is saying, first of all, the budget resets monthly. So it's a monthly budget for $50. So I know that that's low and it's probably not, applicable to the real world, but it'll do for demo purposes. And you can see that we've got $1.78 of that $50 maximum that's been spent so far. So the way it works is as time goes on, you're spending more because of those workloads. So it's not the case that we're accounting for past spend. We're accounting for what's the current spend based on the length of time that budget can go. So $1.78 is what we've got spent so far. Again, really low, but what we'd want to do in this case, in addition to asking, hey, what's this thing going to cost, is to ask, hey, do I have a budget for this? And do I need to be accountable to that budget? Rather than just setting a static value for what something can cost, what type of larger governance do I have in play? And the reason why this is significant is because now you can centrally define in one tool what everything should cost according to whatever cost centers you want to establish in one place. And then you can use a tool like Kyverno, and then Nirmata up levels that with things like Policy Manager, is being able to go and say, all right, let me just tap my centralized resource for whatever governance I have using a policy that I have already installed, and then make decisions there in the cluster at runtime. So let's actually see that. I'm going to go and delete this cluster policy, and I am going to create a new policy, which is very similar to the one that I just showed, but noticeably, this one is now in enforce mode. But what we're going to do in this policy is go, in addition to asking Kubecost, hey, what is this thing going to cost, to ask it, do you have a budget that exists for, in this case, it's a namespace. It could be, again, a cluster, a label, whatever the case is. But if there's a budget for it, we want to not exceed the available amount of capacity that budget has. Now, if there's no budget, then let it go through because we're not statically defining it. But with this additional check here, we're going to try and get that budgetary amount. And then we will only allow it if the remaining budget is less than, or is more than what Kubecost is going to predict. And so all of this is driven through a combination of Kyverno and Kubecost. So let me go ahead and create this in the cluster. All right, and I've now got that policy created, so I'll get policies back. So you can see this one is now in enforce mode. And so I'm going to try and create this deployment, and let's make it super expensive. Now you remember that the budget was only a maximum of $50 a month. There's already a $1.78. Again, I know it's pretty low, but this will do for demo purposes. So I'm going to crank up on the replicas. You can see I've got 9 replicas. Each of these is requesting 300 millicores of CPU and 200 MB of memory. So let's see what happens if I try and create this in my default namespace, which is, again, where the budget exists. I've got Kubecost installed. I've got Kyverno installed. The policies installed. We're ready to rock. We'll see what happens. Oh, shoot. All right. So it's telling me right here, Kyverno blocked it. This deployment, which costs $61.25 to run for a month, will overrun the remaining budget of $48.22. Please seek approval or request a policy exception. So clearly, it just stopped us from spending more than what we were expecting to spend, rather than just showing you a dashboard or an alert, in which case the money has already been spent. We actively prevented it. So to just show that this is not any kind of party trick, that this is actually being determined live dynamically, let's see if we can make this cheaper so that we can let it run. So this was $61.25. How about if I change replicas? I want to try and make this cheaper. We'll try and create it again. Nope, still too much. This is $54.44. And again, these numbers are being predicted by Kubecost live right now, not based on something that's statically defined. This is based on your live cluster with your cloud account, factoring in all of your discounts and everything else that you would actually spend. So it's a pretty accurate number. And by the way, this also will include things like GPU prediction. So although I'm not requesting it here, had I been requesting an NVIDIA GPU, we'll understand what that's going to cost and factor that into the total as well.
You might have to add a few more zeros to that budget. Just a heads up.
Yeah, we'll definitely have to add a couple more zeros there, especially with those A100s.
Yeah.
All right, so 54.44. So let's see what happens if I go down. Maybe I'll go to 200 millicores. And that was created. So we allowed, after calling out to Kubecost, we saw that that was cheaper than whatever the maximum amount that remained in the budget. And the budget has not changed yet because time has not yet gone far enough to see what the maximum is. That's sort of what we're predicting, that that's going to be the remainder of the budget. So effectively, the budget is filled at this point in time. But you can see that the deployment is now running, that's in there. And if we got policy reports, because we have the the policy that's installed and the resource was created in there, we now have a policy report for that, not Nginx. It's totally not Nginx, that exists in that namespace. And this is listed as a pass. And we expected it to be a pass because it was allowed, and Kyverno allowed that to be created. So that is it for the demo. I hope that's been enlightening on putting it into perspective, that you can really and truly, not just, through a sleight of hand, predict and then prevent cost overruns before they occur using this combination. If you want to know more, here's some links. So there's a blog post that I wrote. If you want to see this in detail, if you want to go through some more examples, it's all there so that you can go and check that out. There's a cool blog post from Nirmata and how to do something similar with OpenCost, which, by the way, OpenCost is a CNCF sandbox project that was created by Kubecost and donated to the CNCF. And Kubecost uses OpenCost as its sort of open source core. So you can check that blog out if you're using if you're using OpenCost, and a lot of organizations like that because it's well open, and you can build your own tooling, including your own custom platform on top of it. And lastly, there's a link to the Kyverno policy library where you can see not only this policy that I just demoed, but more like it for Kubecost and a whole variety of other things and other tools that are out there. So with that, I'm going to hand this back over to Randy and take us home.
Hey guys, thanks for joining once again, and thank you Chip, Cy, and Boris for all the valuable information. I'm gonna now open it up for Q&A. So if you either want to raise your hand or put it in the Q&A section or chat, we can get those answered for you. So I'll give people a minute to start putting those in starting now, and then we'll get started with Q&A.
While we wait for folks to drop questions in, and please do drop questions in. We have a cozy bunch of us here, so feel free to chime in. Don't be shy. Chip, one thing that I wanted to call out about that demo that I thought was so cool, and it's kind of an analogy that comes to mind when you're thinking about budgets. If my wife sent me to the grocery store and said, you can spend $6 on apples, $10 on milk, $5 on pizza, not only is that really hard on her to figure out that budget, but it's hard for me to kind of stay within those guidelines. And similarly with Kyverno alone, you could make policies like that. You could say, don't go above 500 nodes. You can only make 10 pods. This is the exact limitations you need to sit within. But I think we can all agree it just makes a bit more sense to say, hey, you can only spend $100 total on your grocery trip or on your namespace, and let the devs figure out how they want to, zhuzh all that around with fitting into that particular budget. It just makes sense. I think what's cool about what we saw here is that Kubecost, you guys have been doing your thing for a while. Kyverno, you've been doing your thing for a while, and the value that we're seeing here is really that integration that brings these two things together. There's actually one quick thing that I want to call out here, if I can share my screen, is kind of that on that point of integration, what we've done in the EKS dashboard using something that we call add-ons. It's basically a bundle of software resources, tools, and we make it a bit easier to install these things. We have a number of official add-ons here, so you can see like the Amazon VPC CNI. But if we click get more add-ons here, of course, I am logged out. Just click this to log back in. These internal accounts are very very restrictive with the timeouts. So let's go back to that cluster. And I'll show you guys the integration that we built here with, if I click get more add-ons here, I can scroll down here, hit Kubecost, and there we go. We've got the Kubecost add-on here where with the click of a button, I can actually have it install that agent, which is going to start scraping that data as well as the dashboard and all that good stuff. And similarly, Nirmata here as well with the Nirmata Enterprise for Kyverno. I'll say another big benefit for customers is that this makes procurement a bit easier because it's all integrated into our marketplace and all of that stuff. So, you can click this, go into the AWS marketplace, depending on, programs that you have set up with AWS. Makes it just a bit easier to get some of these services all kind of hooked in and integrated in the UI. Obviously, there's an API base to it too, so you can do CLI to set up these add-ons and that kind of thing. Just something that I wanted to call out, just the fact that all of these tools are pretty well integrated. And with that integration is really where we see so much of that emergent value.
Yep.
And so
absolutely.
sorry, go for it, Chip.
Just nodding my head verbally in agreement, and also just adding, we've got there are a lot of customers and users that are deploying the whole kit and caboodle through something like Terraform. Like, give me an EKS cluster, give me the add-ons for EBS, give me the add-ons for Nirmata Enterprise, Kyverno, and Kubecost, and have it all in one shot. And which, infrastructure and policy as code, you can version it and store it all together. You can wrap policy around that in your pipeline. Like, having all of these things available in one flick of the wand, whether that be GUI based or API based, super helpful in helping you get up and running quickly with these things, batteries included and turned on.
Yeah, Yeah, absolutely. I do see one question in chat. I am gonna, while I'm sharing my screen, just talk about one more thing here. We have an excellent resource for folks that want to get started with hands-on. How does this stuff actually work? So if you go to eksworkshop.com and in observability section, we have a dedicated lab showing you how to install Kubecost. And we actually do it with Terraform, which you mentioned, Chip, here, which really is one of the best practices for installing these kind of pieces of tooling. So I would definitely say check out EKS Workshop. In the security tab here, we have a dedicated workshop for Kyverno, deploying, managing policies. Now the two aren't integrated today. Wink, wink. If you guys wanted to contribute a module showcasing exactly what you demoed today, Chip, I would be happy to accept a PR like that. Or if anyone is listening at home and wants to contribute, that's also cool as well. We are completely open source here. So just wanted to share that. If you want to get started, check out eksworkshop.com.
Awesome. Cool. It looks like we have a question coming in. And this one's for you, Boris. How can we see all deployments which would get impacted when introducing a new policy in audit mode?
Yeah, so I think there is a two-part answer to the question. First and foremost, if I'm kind of assuming intent on some of this, but ultimately you want to catch the cost before it's on the cluster. And this is throwing us back to what Sai and I discussed with the kind of shift down paradigm. You, through tooling that by utilizing Kyverno and through tooling that Nirmata provides, you can actually scan and look at the resources that you want to apply in your GitOps kind of pipeline. So you can detect and see and get a report of, hey, I haven't deployed anything yet. I want to deploy some things. I'm going to reach out to Kubecost and I'm going to tell you right there in your, Jenkins or GitHub or whatever, your Git pipeline is. This is what this will probably cost you. This is based on the data that Chip was showing already before it hits your cluster. Now, as far as I already have this, I have a cluster and I'm going to apply this policy. When you run in audit mode, your resources are not affected in the sense that you will get that data back with, hey, there is one resource that is going to be affected. There's 1,000 resources that are going to get affected. And this is where the value of kind of what Nirmata brings to the table. Obviously, this data is there now for you to consume straight from the cluster through the policy report engine that Chip was showcasing here. But when you need this at scale and you need this for a large number of objects, as what you're seemingly implying in the question, this is where we provide like our one of our core products, which is Nirmata Policy Manager, which allows you to view that at scale and with kind of a more better human readability of the reporting and metrics and visibility into that.
So Boris, I know with something like Terraform, you can do like a Terraform plan. Is there like a dry run ability with Kyverno? Is there like a way to run it as like a test before it actually applies?
Yeah, so that's what I was kind of referring to. We have a tool out into the wild right now that you can use actually within GitHub as an action or download and play around with, which under the covers utilizes Kyverno. It's called NCTL or Nirmata Cuddle, which allows you to do exactly that by looking at your static and existing code and files and throwing back an analysis with a report with potential remediations with the ability to create an exception, which is all ultimately because it is hopefully in your GitOps flow. You now have much like on PR on pull requests, you can kind of track the history of like, hey, Chip is asking me to change the code here for this reason. You now have the ability to create that historical record of, hey, I am tripping up this policy, but I believe I should be able to spend $1,000 more because I need A100s in my workloads or whatever it may be. And that is a record. That's a historical record that then somebody later down the road can come back and view and understand why an exception was made, what the exception timeout is. There's a big thing that kind of happens sometimes. We create exceptions for things, but we don't time gate them. And if you don't gate something, is it really an exception, or have you just created essentially the new kind of de facto state of the world? But I think that's a discussion for a different webinar, maybe.
Yeah, speaking of time gates, I think we're about to get gated right now.
Yeah, we're up on time. I want to thank everybody again for joining, and especially our speakers for the valuable information. Cy, Chip, and Boris, thank you again. I just want to remind everybody that the recording will be available shortly after we are off the webinar. I hope you have a great rest of your day, and thank you again for joining, and we hope to see you on the next one.
Bye, everyone.
Thanks, guys.
All right.